there now. We'll just explain some of the main things about pointers today. So what I'm going to do is I'm going to write a program where we're going to get a function to swap two variables around. Now, obviously, if we were to swap two variables around with the other type of functions that we've used, we couldn't return both of them, and that's really the problem. So pointers are very useful if you want to return more than one thing from a function or something like that. But they have other uses as well, but they're not that easy to understand, and even when you get fairly good at them, you still have problems with. You still have to stop and interpret it properly. It won't be very, very obvious. But that said, they can be very useful in a lot of situations, but those situations tend to come as you become a better programmer rather than at the introductory stage, okay? So often at the introductory stage you might say, what's the point of this, okay? No pun intended. But obviously they come into their own later on. Now, first thing I'm going to do is I'm going to make a number, and I'll call it int. Now, what I'm going to do is I'm going to give you a quick run through of pointers and printing them out and so on, and then we'll do the swap function, right? So, int num. I'll call it num1 because we'll use that later, right? Now, that num1 is, you can see, an integer, right? If I want a pointer, I can say int asterisk. I'll call it ptr for want of a better word. For a pointer, and what this reads as a pointer, or ptr is a pointer to an integer. So you read it back the way, okay? You must say what type of thing it's pointing to, because oftentimes if it assumes it's pointing to an integer and it's actually pointing to a character, it can miss things out in between. Later in the course you'll see examples of that, or maybe next year you'll see examples of that, but for the minute just take that to be the case. You must tell it what type it's pointing to, even though all pointers are the same size. Pointer is basically just an address, okay? So what it holds is the address of a variable. So I can say something like num1 is assigned 5, okay? I can do a printf of that, %d num1. We'll do our usual get char down the bottom here. And that'll do us grand. Now, so if I just run that, obviously I haven't used the I'll call this simp pointer. See, I haven't used the pointer at all, so that's just printing out the 5 for us there, and you can see that, right? That's fine. Now, what I can say is something like ptr is assigned num1. Okay. Now what that'll do is, well actually that wouldn't work at all, what I've just done there, because I've left something out, right? That's a number, and later on we make it the number 5, but at the minute, because I haven't put the 5 into it, it could be anything. And it would now set this to be pointing to an address that's just whatever happens to be accidentally in this. So what we actually want is to point at wherever this is. And we do that by putting the ampersand symbol in front of it. Remember using the ampersand in the scanf and so on. So what's happening now is ptr is now pointed at wherever num1 is stored. So that I can do this, instead of writing num1 I can say ptr, and if I just did it that way, here's what would happen. Print out that. That's not gobbledygook. That's actually the address where num1 is placed. Okay? However, if I put asterisks in front of it, what I'm saying is go to that address and turn it into the proper number, and here's what will happen. I get my 5 out again. So those two will basically do the same thing. What I could also do is I could say something like ptr asterisk, because I want to change what's in it, is assigned 7. What will happen in that case is it becomes 7, and in fact even if I change this back to being num1, what will it print this time?
Well, you're pointing 7 into it, is it?
Yeah, I'm actually going to the address where num1 is. the asterisk tells me to actually go to the number that's in there and change it to 7. So num1 will actually change to 7. That's what we're seeing there. Okay, so you see the way the pointer is, you can actually get in through the address and actually do something to it. So where this is going to be useful is I'm going to make two numbers here. This is going to make my swap function int num2. I'm going to set them to 7 and 5. Okay. I won't worry about this PTR. We'll get rid of that for the minute, and we'll get rid of all this. What I'm going to do is I'm going to print out the two numbers, %d and %d, and I'm going to say num1, comma num2. Right? Then I'm going to call the sort function, which we haven't written yet, or not sort, swap. The swap function. I'm going to send it the two numbers, num1 and num2, and what I want it to do is to swap the two numbers around. To show that it's done that, I'm going to print them out again, and what I should see is them printed out the opposite way around. So I'm basically going to copy this down here, Control C, I'm going to place it here, and I should see them now the opposite way around. Now we better write the swap function, so I'll put up here, the swap function doesn't need to return anything because it's just going to swap. So void swap int num, and we'll actually call them x and y just so that you see the difference. Int y, okay? Hit it like that. I'll just copy that down. So we write our, so that's just the function prototype up the top, or the declaration, and we'll now do the swap. Now what I'm going to do is I'm going to use a temp in the middle because I have to use a temp to so you okay? You're just going to watch, that's grand. So we're going to make a temp there, so we're going to say temp is assigned x, and then I'm going to say x is assigned y, and then y is assigned x, and then we're going to finish at that, right? Now this program is not going to work first because we haven't used pointers, so here's what's going to happen. We run that. No, I should just put a little /n here, yeah, exactly, to put it onto a new line. Run that. So now we've got 7, 5 and 7 and 5. Now the problem is here that while this has swapped these around, okay, this one here is swapped, it hasn't returned it, and what happens inside the function has nothing to do with what's outside the function. They're completely different variables. However, if I say asterisk here and asterisk here, so I'm expecting a pointer now rather than the actual copy of the variable. Asterisk and asterisk. See you.
So we can
here as well, though, yeah.
No, not yet.
Well, sorry,
yes, you're correct. No, sorry, yes.
It'll work off the two addresses, num1 and num2. Is it?
It won't yet because we need to put ampersand in.
Oh, right.
We need to send it the address of those two, right? Yeah. Now, because these are pointers, we can't just use them the way we have been using, so I need to use indirection, as it's called, use this asterisk to say not the address, the actual thing
What's
itself.
in the address? Yeah.
Yeah. Do the same for all these because we're actually swapping the numbers around. And now what we call x and y are effectively pointers to our original num1 and num2 back in this function. So while previously these were completely separated, now there's actually a link between them. Okay? And if we run that, what's happened?
5 and 5.
So it's 7 and 5 and then 5 and 5. So have we made a little mistake down here?
We should be using temp again.
I should,
Y should
exactly,
equal
yeah,
temp.
absolutely. TEMP. I don't need to put an asterisk on temp because it's not a pointer, it's just a variable.
Yeah. Well, it's just a whole.
Yeah. So 7 and 5, 5 and 7. Do you see how that works? So that's our simple pointers. It's not too difficult. What I said to Frank as well the last day though is that you will have to stop and think about it, and that won't really go away. Okay? And in fact, if it does start to go away, the chances are what you're really going to start to do is make mistakes. Okay? If you don't actually stop and think of it. Main thing to remember is always go backwards with these things. So x is a pointer to an int. Okay? Is that okay?
Yep.
Right, we'll stop.